Electronics for all. Be warning. This video for scientific only. Be careful if you try to do it at home. Hello. Today we will talk about protection circuits. And we will design an easy and accurate one. Protection circuits, like reverse polarity protection, short circuit protection and over or under voltage protection, are used to protect any electronic appliance or circuit from any sudden mishappening. Generally, fuse or MCB is used for overvoltage protection. Here in this circuit, we will build an overvoltage protection circuit without using fuse. Overvoltage protection is a power supply feature that cuts the supply whenever input voltage exceeds the preset value. For protection from high voltage surges, we always use overvoltage protection or a crowbar protection circuit. The crowbar protection circuit is a type of overvoltage protection that is most commonly used in electronic circuits. There are many different ways to protect your circuit from overvoltage. The simplest way is to connect the fuse at the input supply side. But the problem is that it's one-time protection because as the voltage exceeds the preset value, the wire inside the fuse will burn and break the circuit. Then you have to replace the damaged fuse with a new one to make the connections again. Here in this circuit, Zener diode and bipolar transistor are used for automatic overvoltage protection. It can be done by two methods. Method number 1, Zener voltage regulator circuit. This method regulates the input voltage and protects the circuit from overvoltage by supplying a regulated voltage. But it doesn't disconnect the output part when voltage exceeds the safety limits. We will always receive an output voltage less than or equal to the rating of the Zener diode. Method number 2. Overvoltage protection circuit using Zener diode. In the second method of overvoltage protection, whenever input voltage exceeds the preset level, it disconnects the output part or load from the circuit. In our circuit diagram for overvoltage protection is built using Zener diode and PNP transistor. This circuit disconnects the output when the voltage exceeds the preset level. The preset value is the rated value of the Zener diode connected to the circuit. You can even change the Zener diode according to your suitable voltage value. The disadvantage of the circuit is that you may not find the exact value of the Zener diode. So choose one which has the nearest rating to your preset value. Working of overvoltage protection circuit. When the voltage is less than the preset level, the base terminal of the Q2 is high, and as it is a PNP transistor, it turns off. And when Q2 is in off condition, the base terminal of Q1 will be low and it allows the current to flow through it. Now when the voltage exceeds the preset value, the Zener diode starts conducting, which connects the base of Q2 to ground and turns on the Q2. When Q2 turns on, the base terminal of the Q1 gets high and Q1 turns on, which means Q1 behaves as an open switch. Hence, Q1 does not allow the current to flow through it and protect the load from exceeded voltage. Now we also need to consider the voltage drop across the transistors. It should be low for proper accuracy of circuit. So we have used FMMT718 PNP transistor which exhibit very low VCE saturation value. Due to this, the voltage drop across transistors is low. Please note that the red LED number 1 and resistance R1 to showing fault condition in the simulation. As we see now in the real test showing, the protection circuit is working good and regular. Look, the power supply voltage value, and the voltage value shown by the voltmeter. Use the original parts to avoid any damage. And be careful if you will do it at home. I hope that you learned something new in this tutorial video. Thanks for watching. If you enjoyed this video, please like it, subscribe, and click the bell icon to get new video updates.